Types of 3D printers. Whoever thought printing would go beyond books, newspapers, t-shirts, banners, and magazines? 3D printers are the new, or rather old, wow. Apparently, certain organs in the body, food as well as houses, can be printed using a 3D printer. 3D printing, also known as additive manufacturing, is a construction of objects. Any objects using specialized computers and some materials, such as plastic, sand, glass, metal, ceramic, water, plaster, and ink. No model or component is constructed or printed in the same manner as such. 3D printers abound. Each 3D printer has a specific function. This article will discuss some types of 3D printers and the products they are used to manufacture. 1. Fused deposition 3D printers. Fused deposition 3D printers are used for modeling. It uses a process called fused deposition modeling, which is more or less like layering. Thermodynamic products, such as plastic to manufacture parts of automotive. Hyundai, Lamborghinis, and other popular automotive use free deposition 3D printers in developing their products or parts of it. Free deposition printers are not limited to grand products. They are widely known for their detailing. Their detail and accuracy have elevated them in the medical industry. As such, they are used in packaging foods and drugs. They come in various sizes, big enough to fit in a factory and small enough to fit in your house. It can also be built by anyone desiring to do so. It has had an excellent strength-to-weight ratio. Rumor has it that it is one of the cheapest modeling printers on the market. 2. Stereolithography 3D printers. Stereolithography 3D printers is another form of 3D printing used to manufacture medical models of patients. Some of these models include skeletons, casts, the heart, and the spine. Others include game controllers and some concept models. Stereolithography printers are as fast as the day. The standard material for stereolithography printing is resin. Resin has many classifications like dental and medical resins, standard resins, among others. The stereolithography 3D printer, like many others, require the layer-by-layer printing method as well. This form of 3D printing also requires ultraviolet rays focused on an amount of resin. The speed and efficiency of the printer make it very expensive. This form of printing originates with Dr. Hideo Kodama, a Japanese researcher. He used the stereolithography method of printing to cure photosynthetic polymers. Later, Charles W. Hull commercialized it and gave it its present name. 3. Selective laser melting 3D printers. Selective laser melting 3D printers is another additive technology employing heat to produce metals. The heat mentioned here is a high power density type of heat that can fuse and melt metals. Selecting laser melting 3D printing started in 1955 at an institute in Germany. An added advantage of this printer is its ability to produce robust and durable metal parts that cannot be cast. Some of the alloys include nickel, copper, aluminum, titanium, and many others. Tungsten parts are made from selective laser melting. Some rockets can even be printed via selective laser melting. Selective laser melting printers require less material, time, and effort, although the designs are out of the ordinary. This reduces cost production and makes the end products affordable. These printers are used in the manufacturing of tools, orthopedic models. Although these printers are effective, they are not as accurate and are prone to errors. It is not called selective laser melting for nothing. It selectively melts layers upon layers of powder in succession. Because the metals involved are pure, it is costly to operate. The printers for selective laser melting come with their own unique chamber, which can be filled with metal powder and spread across an inbuilt thin plate in tiny layers and amounts. 4. Binder jetting 3D printer. At first glance, you could easily guess the use of the binder jetting 3D printer. It simply binds stuff. Binder jetting require materials like sand particles, plaster, starch, and water to create models. Added materials include dyes for coloring, glue, wax, and some additives to regulate boiling points, tension, and viscosity. The water actually activates the plaster. It is also one of the fastest methods in the 3D printing sector. Binder jetting printers can be used in the construction of houses at a lower cost. They are also used to manufacture alloys, molds, and casts made from sand. If you're on a budget, binder jetting 3D printers are at your service. They are 2-in-1, affordable and efficient, and require lesser amounts of material. Despite being fast, it does not require heating. Sometimes the end products of this type of printing are inferior and weak, porous, and exhibit unfinished surfaces. This is because some of the required materials were not properly mixed. It is most effective when the printing is in a large batch. Binder jetting 3D printing was developed in the Massachusetts Institute of Technology, which is no surprise by a student. The layering fashion is required by binder jetting 3D printers too. 5. Jet fusion. Jet fusion 3D printers and printing are pretty interesting, as they can color the materials being printed. The finished products can also be white and are mostly made of nylon. Jet fusion 3D printing is one of the fastest forms of 3D printing. The printer requires ink and an activator. Unlike the binder jetting fusion printer, the end products have a gleaming surface and are rated one of the cleanest ways to print in 3D. Unfortunately, their quality, speed, efficiency, amongst many others, make them very expensive to purchase. In case you are wondering how fast it is, it can print about 50 parts in less than 24 hours. It requires thermoplastic materials such as nylon, which reduces land pollution. The coloring comes in handy when you are creating a complex model, such as an organ in the body. The different colors will be helpful in distinguishing the unique parts of the model. Some Jet Fusion 3D printers are designed such that the team or person creating the model can monitor how much or how fast production is going. The cost really is worth it, given the many special features. 6. High Area Rapid Printing 3D Printers. High Area Rapid Printing gives itself out. The name suggests a higher speed of printing. It is quite recent and seems to be a subset of stereolithography. It is as recent as 2019, when it was first introduced. It is used in printing large, intricate, and high-strength materials. The High Area Rapid 3D printing is an exothermic reaction and requires very high levels of heat. As a result, the manufactured products are powerful. High Area Rapid printers also utilize resin and oil. It is known to be faster than stereolithography itself. In the face of the COVID-19 pandemic, it proved itself to be very useful. Here is why. Personal protection equipment, such as goggles, face shields, and part of respirators for healthcare agents who put their lives at risk. About 20,000 face shields were printed a week using the High Area Rapid 3D printing. Imagine if the High Area Rapid Area printer were not in existence, the pandemic would have been worse than it got. Besides that, many precious volunteering spirits would have been lost. High Rapid Area 3D printers are pretty expensive, but again, they are totally worth it. 7. Selective laser sintering. Selective laser sintering 3D printers is another additive manufacturing method. It employs laser and sinter powdered materials such as nylon and polyamide to create solid structures. A 3D model is designed whilst the laser binds the materials to be used together. Selective laser melting is very similar to selective laser sintering except for its details and technicality. Selective laser sintering is relatively new, is used for rapid prototyping and low production of components. Mostly, the quality of the finished products depends on the quality of the sinter powder. That includes the roughness, particle size, density, shape, and porosity of the sinter powder. The sinter powder can be made of dry ground ice, lit with nitrogen, and some organic solvents. It can fuse plastic, metal, ceramic, and glass powders alike. This makes selective laser sintering versatile. Many industries employ the selective laser sintering 3D printing method for its low manufacturing requirements. The military, medical field, and aerospace use this form of 3D printing to produce or manufacture hardware components. The laser and the other materials required by the selective laser sintering 3D printers makes it less suitable and highly expensive for residential usage. Artists also use it. Some of the manufactured products tend to have porous surfaces, although they exhibit good chemical resistance and possess high levels of strength and stiffness. 8. Bioprinting 3D printers. Technology's central theme is imitation, and 3D printers are no exception. Consider bioprinting. Organs and tissues peculiar to living things can now be printed using this method. This is achieved by making use of cells, factors necessary for growth and biomaterials to manufacture specific organs and tissues that appear natural. Bioprinting is employed in medical and engineering fields to enhance research. Usually, a biopsy of the organ to be printed is obtained and printed in successive layers in 2D afterwards. They are mixed with specialized liquefied material that frees the models with sufficient oxygen and nutrients to preserve them alive. They are then placed in the cartridge, incubated and matured into the desired tissue or organ. Patients with respiratory, bladder, bone, cartilage, and muscle defects can be treated by bioprinting the models of the organs they need. To be fair, bioprinters are highly accurate as the work they do exhibit an intricate, complex structural makeup. The manufactured or rather printed organs tend to be stronger than the average organ. According to research, bioprinters are not exactly common, so the exact prices can only be assumed but guess away. Unfortunately, bioprinting is not on an enormous scale, so we still have people missing organs and dying from heart and lung diseases and kidney failures. This is one other type of 3D printing. With time, 3D printing may become even better. Some people look forward to such a time. The more advanced 3D printing gets, the easier life seems to get. We are hopeful 3D printers will be able to utilize recycled plastic waste since it uses so much plastic in its printing process. Until then, we hope you enjoy this video. For more videos like this, don't forget to hit the subscribe button and do not leave that like button if you love this video.